Hello everyone, this is another example on this chapter. So the question says that we have an elevator E and then it has a freight with a total mass of 400 kg. That's the freight mass. The hoisting is provided by the motor M and the 60 kg block C. And the motor has an efficiency of 60%. Determine the power that must be supplied to the motor when the elevator is hoisted upward at a constant speed of V. So the constant speed, this is a good sign to say that the acceleration is zero. I mean, that solves a lot of the part of the problem. Okay, so firstly, let's start with the force. Okay, let me say it this way. So what we are looking for, we are looking for the power that will be the force into the velocity. Okay, the velocity, we need the velocity of the, so say that I take any point P. Let me take it here, the P. The velocity is the speed of point P. I mean that since motor and then since the motor hoists that P, that's directly related to the motor speed, and that's equal to the motor speed. And then the force again will be the force developed by the, that is tension in cord of the motor. Okay, for the force, for this one we need the force balance, or you can say Newton's second law to find it. And then for the velocity, we need the kinematic relation. Kinematic equations, actually. Okay, and then let's start. The first thing is that, so I will just draw elevator here again. Okay. So there is a force on this elevator by this rope. I will call this one as T1. There is another one here, the same rope T, same rope T, and then same rope T. Okay, so we have the T1, we have T, and then we have T, and then we have T. So we have 3 T's, and then we have also the mg, which is 400 kg times 9.81. Okay, and then acceleration is 0. As I told, the velocity is constant. And then T1, to find the T1, what I can do is that the block C, so C, it has a weight of 60 times 9.81, and there is a tension T1 in that block. So see here, you can see the T1 has a tension on it. The C has also weight on that. And this T1 is transferred all the rope. That's the same T1 that lifts the elevator up. So from here, I can say that again here acceleration is 0. T1 is 60 times 9.81. If I look at here, T1 plus 3 times T, that will be equal to 400 times 9.81. Okay, so let's do that. 60 times 9.81, that's 589. 589 newtons. Similarly here, it will be 589 newtons. And then from here, I can find that minus 400 times 9.81, that will be divided by 3. So the T value will be equal to 111.8 newtons. Okay, so I have the T value. This is the same T value that develops for the motor. So let me just show it. So same force supplied by motor. As you can see, the motor pulls this one up with the the force, and that's the opposing with the, let me just show it here. So we have the motor here, and then it pulls the rope up with the, so that is the force by motor, and then we have the tension. You see, this tension was 1100.8, and that means that the force by motor is also that part has been solved. Next, the question is, what is the velocity of the rope? So velocity of the rope or velocity of cord, how much is it? Okay, so to solve that one, let me take this picture here and then add it here. Let's see. Okay, so to find the velocity of cord, so take a point on cord. So I will take, for example, this point P. So if I know the velocity of P, then that will be equal to velocity of the motor. See, they are the same stuff. So for this one, I need to use the kinematic relationship, kinematic equations from the lecture 1 or chapter 12. So step 1, we need the fixed data or reference. So that will be here. That's the only fixed point that we have. So that will be the datum. And then from that datum, I have the SP. And then from that datum, I have the SE. And then I have also the SE. See? And then step 2 is that the length of cord is the SE plus the SE, and then plus from P to E. Okay, this part which is constant. Okay, that is SE minus SP, and that's the length of the cable. If I take this point to that point, from here to this point, and from here to that point, is equal to the length of the cable, the cord, which is the constant length. Okay, it doesn't change. Okay, and it's for that instant. And then the rest from here to that place, it moves. But then this part of the cord, I can take it as the constant. Okay, then it will be that if I take d by dt, then it will be that VE plus the VE, then plus VE minus VP is equal to 0. And from here, the VP is 3 times VE. Okay, and then as you can see, that is SE is downwards and VE is upwards. You can see SE is down, but the VE is up. And then from here it follows that, so VP is also VP is also, here it is down, but according to the motion it is upwards. So then we will have, then VE is given as 4 meters per second. So it will be that 12 meters per second. But as I told you, there is the point P moves up. It doesn't move down. So it should be, it is a negative because opposite to SE. Sorry, opposite to SP. Okay, that's for the point P. Okay, then we have all the equations. So we have the Vp, and then that's P, as I told you, is the motor speed, and then we have the motor. So let me just show you. This is our motor. This is the cord, and then there is a force by motor which is 11.8 newtons, and there is the speed of the P here, point P. And then the power will be just an force of motor times the velocity of the point P, and they are in the same direction. So, and I put it this way, positive same direction, so it will be that times 12, and that will be okay 13.34 kilowatts. Then the question says that the efficiency is a 60%. So 60% of a supplied, the electric power is 13.34 kilowatts. Okay, then supplied power to the motor will be just this one divided by the 0.6. Okay, that will be 22.2 kilowatts. Okay, that's the end of the problem.